Okay, we are on page 65 in our notebooks. We're going to be looking at how we can use Venn diagrams to help solve problems. So we're given some information here, and you do not have to use Venn diagrams, but I just think this is a great way to organize information sometimes. Okay, so what we have is we have a situation where we're talking about college students. 56% live on campus, 62% have a campus meal program, and 42% have both. So I'm going to go ahead and draw a Venn diagram. Okay, so we have, I'm going to use L for live on campus and M for the meal plan. Now, usually what I do is I start with both. So the 42 is the intersection. So right in here, I need to put 0.42. Okay, so both is 42%. Now, what it says here is 56% live on campus. So this whole circle right here has to add up to 56%. So what I need to do is take the 0.56 and subtract the 0.42. Okay, so that gives me 14%. What this gives me is the amount of people who only live on campus. They don't have a meal plan. But you can see that whole circle still has to add up to 56. I'm just going to kind of draw an arrow and know that for that I took 0.56 minus the 0.42. Okay, now it also told me that 62% have a meal plan. So again, this whole circle has to add up to 62%. So I'm going to take the 0.62 minus the 0.42, which means that 20% only have a meal plan. They don't live on campus. And again, I don't expect you to do this every time, but just for your notes, I got that by taking 0.62 minus 0.42. So now that I've set up my Venn diagram, I'm just going to go ahead and answer the questions being asked. So right here it says it wants the probability that someone randomly selected lives on campus and doesn't have a meal plan. Okay, so right here I've already figured that out. 14% live on campus but don't have the meal plan. Okay, and then right here, lives in a residence hall but doesn't have a meal plan. Again, I've already figured that out. That's the 20%. Okay, so now let's take a look at this just checking problem. It may be one you want to try on your own before you look at my example. If so, you can go ahead and pause this. So here, again, I'm given information. Okay, so it talks about, they've discussed that you sample some pages of your book to see whether it held a graph or displayed data. And they did this, and this is what they came up with. So we're talking about data and graphs. So I'm going to go ahead and make myself a Venn diagram. So data and graphs. It says 48% of the pages had some kind of data display. 27% of the pages had an equation, and 7% of them had both. So actually, it's not a graph. Let's change that to an equation. So the both, I'm going to change that to 0.07. That's going to go in there. Now it says 48% has some data display, so I'm going to take 0.48 minus 0.07, and that's going to give me 0.41 here. And then over here, 27% had some kind of equation, so I'm just going to take that 27%, subtract 7%, so this is 0.2. Just a reminder, when you're dealing with your percents, it's always a good idea to change them to decimals. So I did part A. There's my result in a Venn diagram. Now, they want what's the probability that a randomly select page had neither a data display nor an equation. Okay? So they're looking for neither in this case. So that's going to be outside of the box. So in this case, we know the sample space, all the possible options, has to add up to 1. So to get part B, I'm going to kind of use the complement. So a not one of those. So I'm going to take 1. So the probability of neither is going to be 1 minus 0.41 minus 0.07 minus 0.2. Okay, that's how I'm going to figure out the probability of neither, because everything would have to add up to 1. So I wanted the area outside that box. This is actually what I want there. So 1, just going to do that math. Okay, so about 32% had neither. And then for C, it says, what is the probability that a randomly selected sample page had data display but no equation. And again, I've already figured that out. So C would be 0.41. Okay, let's take a look at our next just checking. It says, opinion polling organization contact the respondents by telephone. Random telephone numbers are generated and interviewers try to contact these households. In the 1990s, this method could reach about 69% of U.S. households, according to the Pew Research Center for the People and the Press. By 2003, the contact rate had risen to 76%. We can reasonably assume each household respondent is independent of each other. What's the probability that the interview successfully contacts the next household on her list? Well, we're going with that 0.76. So 76% chance they're independent, so there's a 76% chance that my next phone call will happen. Okay, for B, the interview successfully contacts both of the next two households. Now, if you remember way back when you had to do the probability, when you want two independent events consecutively, you're going to multiply them. So two households would be 0.76 times 0.76. So I'm just going to go ahead and multiply those. You could also take 0.76 squared. Okay, so the probability that you're going to get both is going to be about 0.5776. Now for C, it says the interviewer's first successful contact is the third household. So that means the first two are not successful. So I'm going to have, let M be not, I want not successful, and successful. Okay, well, not successful and successful are complements. Okay, so kind of over the side, I know the probability that they're not successful is going to be that 1 minus the 0.76. Again, those events are complements, so that means it's going to be 0.24. So in this case, I'm going to take not successful times not successful times successful. For some reason, I was not putting that in my calculator right. So that's going to be about 0.044. Okay, and then let's look at letter D. Letter D says the interviewer makes at least one successful contact among the next 5 households on the list. Okay, so there's 5 households. A lot of times when you have at least one, you want to use what's called the complement. So the probability of at least one, I have to think, what is the complement? What is the only event that is not at least one? And the complement of at least one is none. So I'm going to do 1 minus the probability that there are none, so no successful. And there were 5 households, so 1 minus 5 attempts, no success. So 0.24, 1 attempt, 2 attempts, 3 attempts, 4 attempts, 5 attempts. Now, I just wrote this out because there were 5 phone calls. Generally, let me move it up so you can see. So 1 attempt, 2 attempt, 3 attempt, 4 attempt, 5 attempt, or the same thing, which I would do if I was doing them on my own, I would just raise that to the 5th power. So I'm just going to go ahead and calculate that. So the probability of at least one is 0.999.